Hi everyone, greetings from Montreal. I wanted to give a brief overview of how to do the QC reports with HALFpipe. You will have for each subject in the dataset, you will have an entire folder with all of the different report images. And as you can see, there's a lot of different subjects in this dataset. So I'm going to open this index.html file in here with a Chromium-based browser. So that will be Google Chrome, Microsoft Edge, or Brave. And those are much faster than Firefox for this, but Firefox also works. So now let's go to our browser. And what we can see on the top is that, oh yeah, 2 subjects didn't finish in my processing. Most of them succeeded and 1 has an error. So I think that's fine. And then we can see the summary. And so here we have 1 box for every kind of image. So that means some subjects have more than 1 image. So we have 220 subjects, but each one has maybe 2 runs or 2 different tasks. And then we can see kind of what is our QC decision in the end. Right now we don't have any ratings, so they're all in the no rating category, but they might later be in the good, uncertain, or bad categories, where good would be the data that we include. Uncertain is kind of the category that we label things so that we can ask colleagues for feedback and review them. So that means at the start you're going to have lots of uncertain images, but once you finish QC, there should ideally be 0 of those left. And bad are the ones we're going to exclude. So in the bottom panel, so I'm just going to minimize my other panels, we see a histogram of QC metrics. And so we can see that, yeah, some participants do have big outliers in terms of motion. These are the number of motion spikes, or the percentage of motion spikes. We can see that there's also a big spread with independent components classified as noise by AC aroma, and last one is the temporal signal to noise ratio. Okay, so now that we've looked at our summary, let's go to explore reports. So we do that by, we can either click on one of these boxes, that will take us straight to the images, or we can use the menu at the side, which gives us a few more options. So we can import and export. So export will download a file in your browser that you can use to send to people that they can import, for example, to continue where you left off. And like, you can also share with collaborators and, well, hopefully me, so that we can use it for the next HALFpipe paper. And so then in our reports view, we can sort either by image type. So that will make it very easy for us to go through each of these different reports images in turn. So like first focus on skull stripping, and spatial normalization, then go through TSNR, confounds, ICA-based artifact removal, and finally spatial normalization. So I think we're just going to kind of do that. So this is my personal favorite way of doing it. But you can also sort by subject, and that kind of groups all of the images nicely by subject, and we can go through different image types and can cross-reference more easily across images. So that's kind of a matter of preference. I prefer going by image type, so that's what we're going to do in this video. So since we actually have to look really carefully, I'm going to click on the image. So I'm going to, where it says click to zoom, we can just click anywhere on that box and it will zoom in and make the image as full screen as possible. And then we can look for each one of these slices and make sure that the red line delineates clearly the brain tissue from the surrounding skull. And in this case, I don't see any problem, so I'm going to use the W button on my keyboard to mark it as good, and then press the D button on my keyboard to go to the next. I can also press A to go back, so A, D, back and forth. W is good, S is uncertain, X is bad, but this image is good, so I'm going to press W again. So that kind of lets you do this QC with just one hand, and yeah, maybe listen to some music, relax at the same time, focus on the images, and hopefully this will be a quick experience and also help improve the quality of the science we're doing. Okay, so we're going to go through all of these images, and I'm not going to do all of them, but we can see that all of the brains kind of look different, and that sometimes we will have things included that are like Well, they're next to the brain, but they're not gyri and sulci. They're like the meninges. So this is the dura mater, like one of the meninges that surround the brain. And usually we don't want that to be included in the red line, but the x equals 0 slice is usually kind of a joker because it's like right in between the hemispheres. So if that one looks a bit odd, that's usually okay. And the way we can also double check that is by cross-referencing. So by going back to this tree view, we can actually click now on spatial normalization. We're going to jump to the same image for this, to the spatial normalization image for the same subject. And we can actually have a look and make sure that, yeah, this one definitely still looks a bit odd, but these ones next to it, they're fine. Like, so what does this image show us? So here again, we see the red line, the bright red line, delineating the inside of the brain and the surrounding tissue. But this time, it's the image that's been normalized. So it's been shifted and warped to match the template brain, which in this case is the MNI template. And then we see overlaid in light red the cortical ribbon, so that's kind of the line delineating gray matter from white matter. And we see various subcortical regions and ventricles in colors, as was in purple, the cerebellum. And so we want to make sure that this atlas that is overlaid on our normalized image matches the image. And in this case it does, so we can also mark this as good. So pressing D on my keyboard to go to the next one, checking all of these images slowly and carefully, making sure that everything is aligned. And if at some point I feel like something is unclear, we can always zoom out and go to this related images tab. And so that's gonna give us some additional reports that are generated by fMRI prep. One that I really like is this STD T1 weighted SVG file. So we can click on that and that will show us an animation going between the template and the T1 image. And it's really nice because then we can also like look in much more detail what is going on, not just in terms of the atlas, but in terms of the actual images that are being aligned. So this related images tab, if anything isn't clear from these kind of simplified reports images, they're always great to go in and dive in more detail. So this is the overview of the T1 weighted normalization. So now let's jump to the EPI or functional images. And so here, the first one we see is the TSNR image. And TSNR is short for temporal signal to noise ratio. So it's the mean of the image across time divided by the standard deviation across time. As the mean is kind of the signal and the standard deviation is kind of a measure of the noise, which we expect to be homogeneous across the entire image. Of course, not perfectly homogeneous because we have a biological system that is noisy. But we also don't expect there to be artifacts. And the manual outlines a bunch of those. That could be, for example, stripes or just parts that are just completely dark or far too bright, which may indicate a problem in the scanner, both software or hardware, that make the data unusable. And here again, we can click to zoom, carefully review every single slice, and then press W to mark as good, because I think this one is very nice. So every data set is going to look different because every scanner is different. And usually it will take a few images to kind of get a feeling for, okay, how do the data from this data set look? Is this normal or is this unusual? Is this okay or not? But so far, these all look pretty nice to me, and I'm quite happy with this. Let's go to the EPI confounds tab. So this is also called a carpet plot. And what the carpet plot shows us, it shows us time series of the average across all voxels, also called the global signal, the average across CSF voxels, so like the ventricles, average across white matter voxels, the DVARs, which is a measure of the derivative across time, and finally the frame-wise displacement, which is motion in millimeters. And then in the bottom we see all of the voxel time series in kind of a heat map. And what we want to see here is that the time series again are kind of they're always going to have noise because it's a biological system, but they should be consistent with a biological system. So for example, what we see here is that there's this big change here in signal, like this big kind of white line, but that also kind of coincides with a motion spike. So that means the participant moved and that had a big impact on lots of different time series. But since we're going to be denoising the data, that's fine. And that's well within parameters, so we can mark this image as good. So I'm going to press W on my keyboard and D to go to the next image. So the next one has even less motion, really good quality. I'm going to mark that as a good one again. And this one kind of looks like yeah, the TV when the cable was unplugged back in the day. So that's always a good sign. And please check out the manual for some examples of good and bad images, what to look out for. So the ICA-based artifact removal is very interesting because it kind of shows you all of the different independent components that were found by Melodic and classified by ICA Roma as either green, so include signal, or red, which would be noise. And those would be regressed out if you're using ICA Roma. So these can be kind of, usually you would look for, is there a default mode network in the green ones? Is there something that's consistent with the brain networks that we expect? And most importantly, are those actually green and not red? Because if we're regressing out kind of important brain networks, then, well, that's going to be really bad for our data quality and for anything we want to do with the data. But that's a lot of work we've noticed. So we're kind of skipping over ICA-based artifact removal if TSNR and confounds look great. So we're kind of saying, let's look at this only if the other ones are inconclusive. So I would just recommend skipping over this one for now, but if you want to have a look, or if things are inconclusive and you want to have a look, there's some great examples and explanations in the manual. Finally, EPI spatial normalization, which is the exact same image or the exact same image type as the T1 weighted spatial normalization. But in this case, we don't see the structural image in the background normalized to the MNI template, but rather the functional image. And overlaid is the same atlas. And so we want to again make sure that the image is consistent with what we would expect from the template. But this is going to be much more fuzzy because, of course, in the functional image, we have much lower resolution than in the T1 weighted image. So that means that the background is going to be much more blurry. It's going to be much less delineation between the white matter and the gray matter. And some of the subcortical regions aren't actually going to be all that visible, just because we are lacking the resolution and contrast in the functional MRI scans. Nevertheless, I think this one looks great. And as always, there is the animation from fMRI prep that we can always jump into to see things in more detail if we're uncertain. And I feel like those always are the best way. Kind of ideally, we would look at those for every participant. But when we see a beautiful alignment like this, we don't need to look at it. We can save a bunch of time by just marking this one as good and going to the next one until we see some discrepancy, and then we can evaluate the animation in more detail, see whether this discrepancy is just an unusual participant, maybe some unusual brain anatomy, some unusual features, or whether there's actually a problem in processing and we need to exclude that participant. So for those problems in processing, please see the manual for some examples. Okay, so that's all of our 6 images, well, 5 plus 1 optional one. And now once you're finished with, let's go back to the chart. Once you're finished with rating, then all of these dots and squares will have been colored in. And I would recommend that every day you spend on rating, at the end you export and save a JSON file, because right now all of these ratings, all of my hard work is just saved inside my browser. So if I clear my cookies or I go to a different computer, all of these ratings will not be there. And they might be lost forever. So please be mindful of exporting and saving and backing up those files, because otherwise your hard work might be lost. Let me know if there's any questions or there's anything I can help with.